They started by imagining the simplest object possible, one that would absorb all light that falls onto it and perfectly emit radiation based on its temperature. They came up with a hole in a metal cube. This hole is a perfect black body because any light that shines onto it will go straight in, bounce around inside, and eventually be absorbed. But this also makes it a perfect emitter. Any radiation inside the cube can escape through the hole unimpeded. Theorists reasoned that electrons in the walls of the cube would wiggle around, emitting electromagnetic waves. These waves would then bounce off the other walls. When you have two waves of the same frequency, where one travels to the right and the other to the left, they can interfere in such a way that they create places where there's no wave amplitude, those are nodes, and places where there's maximum wave amplitude, the antinodes. Waves like this are called standing waves because they don't really move left or right. And inside a cavity, given enough time and reflections, it is only these standing waves that survive. All the other ones just cancel out. So a sort of order emerges from the chaos. In 2 dimensions, standing waves look something like this. For shorter wavelengths or higher frequencies, you can fit more and more different vibrational modes inside this cube. So that in 3 dimensions, the total number of modes is proportional to frequency cubed, or 1 over lambda cubed. The expectation was there would be more and more waves inside the cube the shorter the wavelength. This led directly to the Rayleigh-Jeans law. At longer wavelengths, it matched the experimental data pretty well. But at shorter wavelengths, the theory diverged from experiment. In fact, it predicted that at the shortest wavelengths, an infinite amount of energy would be emitted. This, for obvious reasons, became known as the ultraviolet catastrophe.